Please remember to use a source code versioning tool. This is really, really something that will save your life later in your project's life. Then the second thing you need to do when when you start working on a project is to identify a language and a framework that you're going to use to realize your project. So the important thing to keep in mind is to use a popular language or a popular framework. Why? Because if you use a language or a library or a framework that is not very popular or hasn't been around for long and you don't know what the future of the tool will be, you might encounter a situation where in a couple of months that library or that framework will be abandoned, and then you won't be able to update your project anymore. So this will cause problems that would mean that maybe you would have to start over all of your project. So these are things that you need to keep in mind. Also, in addition to using popular tools, you need to choose the correct one relevant to your use case. There are some questions you might ask yourself to choose what language or what framework to use, such as what is the targeted platform that you want to use for your project, what is your time to production, what are the performances of the tool, and what you expect. Do you need a community around the project? Does your team have skills to master that language or that framework, or does your team have time to acquire those necessary skills? Nowadays, web development basically in most cases means JavaScript or PHP or Python or maybe other languages. So when you choose your tools, choose your frameworks, choose them wisely, and keep in mind that these have to be stable. They have to have stable versions. They have to have been around for a while. You need to be able to rely on them because this will be the basis of your application. So once you have chosen the language and your framework, the next step will be choosing your libraries, choosing your libraries. So what are different libraries and dependencies you might have in your project? Well, that of course depends on your use case, but you will use a lot of existing libraries that will allow you not to reinvent the wheel and not to write code that already exists and has widely proven efficient. For example, you can use libraries to do HTTP calls, maybe to log in, to have some security in place. I don't know, a lot of anything basically. There are many, many libraries that exist. The thing to keep in mind here is that you need to keep your dependencies up to date and you need to use stable versions of your dependencies. Again, this point is almost the same as the one I covered before. This means that you need to be able to rely on your dependencies. You need to be able to know that they will not be abandoned, that the maintainer will keep them available for you. You also have to make sure that you follow what is going on with your dependencies. Because once you're working on your project, once it's live, it's in production, you are working on fixing bugs, you are releasing new features, and maybe you do not prioritize time to update your dependencies. But then a couple of months later, 6 months later, a year later, you will realize it's too late to do that, or it will require much more effort to do so. Because if you do this on a regular basis, this means that you will have little fixes to do. Whereas if you wait for a while to do that, then you will have accumulated a lot of things to do, to change, to adapt in your project. Also, your code base will grow, so you will have more code to update as well. So how can you make sure that your dependencies are up to date and that you keep an eye on them? Well, there's a tool that is called Dependabot, which you can plug into GitHub or GitLab or anything else, which will notify you when there are new releases of the dependencies and libraries that you use. This is very, very useful. This means that you do not need to be actively looking for any changes in your libraries, because this can be very, very time consuming. But here you will have a tool that will do it for you and will notify you and create pull requests on your project and then you will choose if you want to merge or wait or the action that you want to do. to do this. Now, so you have a Git or a source code versioning tool, you have your language and framework, you have the different libraries you want to use, they're up to date, you have started working on your project. A thing you need to keep in mind as well is that you need to use standards for code formatting. So what does this mean? This means that you need to use tools that will automate the decisions that you will make on the structure of your code. So here we're only talking about readability and the way the syntaxes of your code. This will allow you to increase the maintainability of your applications and the readability of your code. This requires your team to agree on some standards that you want to implement. This will allow you also newcomers in your team to be quickly comfortable with the code and to be able to understand it more easily. This will make the code that your team produces more consistent instead of every individual doing everything the way they like. And this will also allow the reviews of your code to be much easier. And moreover, this will reduce the time that you will spend on fixing style instead of actually implementing business logic for your application. So here I put a quick example with a pull request. So I just here added a feature to sort some data, okay? So this is a case where I use an automatic tool that will fix syntaxes of my code. And you can see I can easily read the changes that have been made to my code. And as opposed to this, if I don't not have strong standards, if I don't have tools that will allow me to automate this kind of behavior and structure, this means that every time I do a pull request, I will maybe override something another teammate has done, and this might result in a pull request that will look like this. And this is only an extract that I did expressly for this use case. You can see here the same sort feature I have added on line 310, but you can see that above and below, there are many other changes that are only related to some spaces or tabulations, but the review is very hard because we cannot easily identify what has changed in my code and where the actual new feature and new maybe bug fix is. So please keep in mind, you need to use automatic tools that will respect the decisions that you have taken as a team on the structure and the syntaxes that you want to use in your project. Next is the same, but that applied to the logic of the implementation of your code. So this means that you need to use standards to do so. There are three different sub-subjects on this. So design patterns, object-oriented programming, and different programming principles I will cover just like in a few minutes. So first of all, design patterns. Design patterns are standards that have been implemented for many years by many developers, and that basically implement a way of realizing a feature. There are many design patterns that exist. There are many websites, many books that allow you to learn more about them. I'm going just to cite some of them that we see often in different projects. I think the most widespread one is factory. Factory is a principle in which you have a class that is responsible for creating and configuring your objects of the correct type depending on an input that you will give to the factory. You can have an observer design pattern which will allow you to subscribe to events happening on an object to trigger some other behavior. You can have specifications, you can have use cases, etc., etc., etc. There are very many design patterns, and the reason why it's important to implement them is that your code will be more maintainable, more easily maintainable, and that any newcomer in your team familiar with the design patterns will be easily able to identify your code, to know where to look for some features, how to fix them, and how to get familiar with the application. So this will reduce the time that your teammates will need to be able to be efficient on your project. So another aspect of this is to use object-oriented programming. So why is this important? Well, of course, it depends on the language and if the language allows you to use object-oriented programming. And whenever that's possible, this will allow you to have strong types and allow you to add abstraction to your code. This having classes and objects will mean that in different places in your code, you will make sure that you have the correct types of objects that you manipulate. So this will result in less errors of any type, basically. And as I said, this will allow you to do abstraction of your code via interfaces, abstract classes, inheritance, etc., etc., etc. And this leads me direct to my point number 3, with using different programming principles, such as solid, dry, or KISS. So solid is basically an acronym that unites 5 big principles of object-oriented programming. So first is single responsibility principle, which means that one class should only be responsible for one thing. So if you have on your website or an application a feature that allows you to create an account for a user, send them an email, and generate, let's say, a list of suggestions for their account. You can have one class that does it all. You can also have 3 different classes, which each are responsible for one thing, which is much more suitable, because this means that your your code is more easily testable. This means that one class does one thing, so you know where to find which logic. You will be able to more easily find coherent names for your classes and for your services, etc. The second principle of solid principles is open-close principle. This means that in your software, the entities, meaning classes, modules, etc., should be open for extension, but not for modification. I will not go into detail because this will take me a lot of time, but keep in mind that this means that you should be able to extend your objects to manipulate them, but you should not be able to directly modify them. The third one is least scope substitution principle, which means that basically if I replace a child class with a parent class, I should still be able to call the same methods and functions inside it for my objects. The next one, the fourth one, is the interface segregation principle, which means that many client-specific interfaces are better than one general purpose interface. This means that I need to separate my features and my functionalities into separate interfaces instead of having a big one which does everything. And finally, the last one is the dependency inversion principle, which basically means that I need to be able to rely upon abstractions instead of concretions on my dependencies. This also joins the dependency injection pattern, which is a whole other subject. It's on its own. This deserves a presentation. It's a very, very interesting subject. But these are the guidelines of, let's say, on these solid principles. So please, these are very important. If you are using object-oriented programming, you need to be able to be familiar with them. I also mentioned here dry, which means don't repeat yourself. So remember to, when it's necessary, do some abstraction, extract some code, etc., create services when needed. KISS means keep it stupid simple. So keep things simple. Do not try to do things that are over-engineered, that are maybe a little too complex when it's not necessary. Remember, the goal #1 of your application is to be able to maintain it easily. So you need to be able to do some abstraction, to use design patterns, apply some principles, but remember, rule #1, do not over-engineer and keep things simple. Okay, I hope you're still here, still following my presentation. And now let's move on to the next part, which is about choosing the right and the appropriate database. So soon as you have an application that needs to store some data, save information somewhere, you are going most likely to use a database. Nowadays, there are two types of databases that you can use. There's more classical, let's say, SQL databases and the NoSQL databases. NoSQL stands for not only SQL, which these databases were developed in the late 2000s, and they focus on scaling fast queries. They will allow you to have frequent application changes and make programming simpler for developers. Um, the more classic relational databases as we know them, with structured query languages, SQL, were developed in the 70s, and their focus was on reducing data duplication and storage. And the SQL databases, as you might know, have strong rigid structures and schemas that you need to be able to update via migrations when necessary. Whereas the NoSQL databases are more flexible, they don't have a strict schema, and they are more flexible. But you need to make sure to ask yourself the right questions when you choose one. Um, the the NoSQL databases are more efficient when you are reading for read instructions and with big data sets. Whereas a SQL database, in most cases, will be more efficient for write operations. So it really depends on the application that you are writing and the aim of what you're going to do. So now we have covered most of the things that you need to do and have when you are starting or working on an application. But there is another aspect to developing an application, to writing code, it is to write tests. So this is something as from my personal experience, this is very often neglected by your customers, which at first glance will say that this will consume time and that this is not a priority, but it actually is. The thing that is that we very often underestimate the importance of tests because we do not realize how useful they are and how much time they will save us later. Uh, Once you have written tests on your application, if you have a bug, you will be able to quickly identify it. If you modify some code, your tests will be executed, and then you will know that you have introduced a regression that you might not have thought of. This will avoid having a lot of bugs in production. This will also save time for manual tests before you deploy your application to production. And this will make you more confident in the code that you produce. There are three types of tests that you can use and write in an application. First, there are unit tests. The goal of a unit test is to automatically validate that each unit of software performs as expected. So unit testing is done during the development, of course, of our application, and it isolates a section of code that we need to verify. A unit test will be applied to a function, to a method, to a single procedure module. So this will really test small bits of your code. Then there are functional tests. Functional tests validate that the software system works against our functional requirements and specifications. So the aim will be here to test each feature of the software application by providing appropriate input and verifying that the output meets our expectations. This will be done, functional tests will be done to test user interfaces, to test our APIs, to test that database connections work properly, that the code that we've written behaves the way we expect it to do, and will be useful also in cases such as client-server communications, etc. So remember, unit tests will only test small bits of your code, functions independent one from each other, from each one from another, and functional tests will test a behavior that is expected. So if I have an API that has to implement some logic, I will give it an input. So do it in the API call, and then call my function, call my API, and check that at the end of the execution of my API, the state of my application, maybe something saved in the database or something I got in return from my API, corresponds to what I expect. And then thirdly, there are end-to-end tests. End-to-end tests will allow you to test the whole of your application. So as you know, nowadays applications are more often done in two parts. You'll have the front end of your application and the back end. And the end-to-end tests will allow you to test that the whole of your application behaves as expected. It really tests the life cycle of our development and the features and the performance of our application. Here I have put some examples of tools that you can use to implement different unit functional and end-to-end tests. This is something that you must not neglect, and you need to remember to do them. We often, as developers, tend to listen to our customer, or well, we have to listen to our customer, of course, but we need to make them understand the importance and the value of writing tests and gaining time through them. Then comes the part where we are going to need a CI and a CD. The goal of this is to automate as much as possible. So now let's talk about what a CI and CD is. CI stands for continuous integration. Continuous integration is the part and the practice of merging all developers' working copies of a shared mainline in several times a day. So this means that if we are a team and we work with a Git, for example, we have each our branches, we develop on our different features. And the idea of continuous integration is to be able to combine the code that everyone produced that is reliable and have it all in the same place. So this is an automation process for developers. And a successful CI means that new code changes to an application that we've done are regularly built, tested, and merged into a shared repository. So this is the solution to the problem of having too many branches of an application during the development phase, and then having too many conflicts between different branches and between different features we develop with the team. The next step of this schema is the continuous delivery part. Continuous delivery means that as a developer changes an application, any changes that we as developers do to an application will be tested and updated into a repository, and they can be deployed to a live environment by a team, so by an operations team or by developers themselves. So this part will cover the problem of poor visibility and communication between the developers and the business teams. And the continuous delivery is there to ensure that it takes minimal effort to deploy new code. So the step 2 here means that we are going to be able to build and have ready and have our project ready to deploy to the users at any time. And lastly, the continuous deployment means that we will be able to deploy the project that we have built in step 2 very easily to a production environment. So this is a workflow that you can implement in your projects via tools such as Jenkins or Travis CI or GitLab CI or any other tool, because there are many of them. And this will allow you to automate a lot of behavior. And as you can see, if you paid attention to what I said in step 1, your code needs to be tested all the time. to make sure you do not introduce regressions. And this means that at the end of step one, when your code is executed and tested, this is where your unit and functional tests will be very, very useful, and end-to-end tests as well. This will allow you to write some code, push your branch to Git, uh, create a pull request, and then run your CI on your pull request. Make sure that there are no tests that you have broken, no any behavior, no surprises with what you've made, the changes you've made, and then you know that if you merge your code, nothing breaks, and your application is ready to be sent to production. So this will make sure that at any time, if your code is merged, when your code is merged to a common branch, this branch has to be functional and it can be pushed to production at any time. So okay, now we have everything. We have a CI/CD, our application is ready, and we pushed it to production. Something we need to keep in mind as well is that we need to monitor our production environment. We need to know what's happening on the servers. We need to know that everything is running okay, or if there are any bugs or logs, something we need to be able to consult. So we need to be able to read logs. Usually we use tools such as Kibana, for example, for such things. We can configure alerts on our server status to make sure that if a lot of CPU is used, we need to be notified. If there's no more disk space for some reason, we need to be notified, etc., etc., etc. So again, these are things that you can do as a team. Maybe you will have DevOps in your team that will help you with this. Maybe you will need to do this yourself. But this step is very, very critical to ensuring that your production environment runs correctly and that you do not have any surprises that you are not aware of, especially. One thing that will help you with this is deploying your application to the cloud. So why? As you might know, this has become very, very popular, deploying applications to the cloud. Well, I would say there are several reasons. One of them is mainly that there is less hassle for the team, that in most cases you won't have any server management to do yourself. Deploying applications to the cloud will mean that your application will be scalable more easily because most cloud providers take care of this. It will also allow the team to concentrate on the application because there will be less time and resources invested in infrastructure management. And also, it's quite easy to deploy applications to the cloud. Here I have a small table describing some of the different types of cloud you can use. Of course, some are missing, such as SaaS. But unless you're developing a SaaS application, in most cases you will have maybe one of these situations. So first is infrastructure as a cloud, where you will be managing your operating system, your containers, the middleware's runtimes, your data stores, so the databases, and your application code. But you will not be handling any virtualizations and any hardware because the cloud provider will do it for you. If you are in the container as a service mode, so the second column, then you won't have any operating system to handle either. You will only provide the containers that you want, and the levels above as well, but the rest will be handled by your cloud provider, and so on, as you can see on the other columns. So if you are doing PaaS or FaaS, so FaaS also means serverless cloud. So in serverless cloud means that you only deploy your code and everything else is handled by your cloud provider, which is very, very powerful. Nowadays, all web applications, at least most web applications can be deployed as serverless applications. So yeah, here's just an overview of what is possible to do in the cloud. Of course, you should take a look at this. It's very powerful. It will liberate a lot of time for you and your team. Nowadays, so as I said, you can do serverless, you can do Kubernetes, where you'll have your containers. There are many other ways to do serverless. You can use a Google Cloud Run. You can use basically everything that most providers will give you. As you know for sure, the most common cloud providers are Amazon and Google because they are the most active actors, and it's very easy to use their platforms. There is good documentation that will allow you to easily test things and to quickly be able to have a working environment for your production. One of the other aspects of being a developer that might be often not not anticipated by some let's say younger developers is that you will be working in a team, and so you need to work with your teammates and do not neglect the importance of communication. Uh, Working in a team means that you will have to respect the decisions that are made by your team. This means that sometimes you might not agree on a personal level, but if the rest of the team makes a decision they all agree, you have to respect it anyways. It also means that you have to have transparency in in the job, in the work you are able to do. You will need to communicate to your teammates how you're doing, if you're able to finish your tasks, if you need some help. This, of course, joins the whole goal of this conference, the agile working. This means that whether you're working in Scrum or Kanban or whatever, you need to be able to share with your team how the progress of your tasks, to offer help or to ask for help, and be just transparent on how you're doing. And finally, of course, you need to prioritize the product and the team over your personal wants and needs. And basically, this is pragmatism. You need to keep in mind that, of course, it's very nice to work in a team. Of course, it's very nice to be able to test the latest new library or tool that you would like to, but it's not always necessary or useful for the product or the team. And last but not least is that you need to be able, you need to force yourself to do some technology intelligence. Why is that important? It's important because the web environment evolves very, very quickly all the time. Uh, we live in a world where new libraries, new frameworks, new tools are born every day. And as I said before, some of them will be abandoned in a couple of months, but some of them will become the next most popular framework that you will need to be able to handle. And for this, you need to keep an eye on what's going on the development world. You need to read blogs, read books, read articles. You can use MOOCs in a video format to do this. You need to test new things. You can do proof of concepts on different small projects in your spare time. And of course, you need to be able to not be afraid to question everything that you already know or are used to, and you need to be able to adapt. Otherwise, you might become as this grandma who will become obsolete much more quickly than she would like to accept. Thank you for listening. I hope you enjoyed my talk, and I